podcast. Tonight we're going to look at the effect of concentration on E cell. So effect of concentration on E cell. And this is going to relate back to really Q in equilibrium constants. There's even kind of a trick that we can kind of look at Le Chatelier's principle, and it's not really Le Chatelier's principle, but we can say it's Le Chatelier-like in predicting what's going to happen to E cells, and we're kind of going to cover that tonight. The equation that determines this for us is called the Nernst Equation, but that's kind of just a quick overview of what we're going to see in just a second. So, effect of concentration. The first thing is, just to remember, we had two separate equations on 14.1. We had a zinc copper cell, we had a magnesium aluminum cell. And whenever we determined our E values, if you remember on that podcast I said that E is not stoichiometrically dependent. So it doesn't matter for our aluminum magnesium, we had 3 electrons in one half cell and 2 in the other. So we had to multiply our cells by 2 and 3 so that we had a total of 6 electrons being transferred. So the effect of concentration is just kind of real quick. E cell is not stoichiometrically dependent, but concentrations are. Okay? So whenever we have E cells that have a little knot above them, this is, again, making the assumption that our concentration equals 1 molar solutions. Alright? And E cell knot is a standard condition. Alright? So our new equation is going to be called the Nernst Equation. And again, Nernst is on your equation sheet, so it's nothing that you have to memorize. But the Nernst Equation shows the relationship between E cell and our concentrations if they aren't 1 molar. Alright? And it is essentially this Nernst Equation equals E cell equals E cell naught. Okay, so that's just what we're going to equate. That's just our reduction minus oxidation. Minus RT in F times the natural log of Q. Alright? And just like back in equilibrium, Q is K, K is Q, but Q is not at equilibrium where K is at equilibrium. Alright? And if this happens at 298, then we can just have E cell naught minus 0.0592 over N. And typically I think this is on your equation sheet as log of Q. We could also use the 0.0257 natural log of Q. Alright, and that just gets mixed up, and you'll have both of them, and you'll use both of them depending on what kind of mood you're in, or what the equation asks for. Alright, so just a reminder, Q then is always products, concentration of products, divided by concentration of reactants. Alright, so here we go. We are going to use our two equations from 14.1 podcast, and we're just going to change the equation, or the concentrations on them. So our first equation, our example, is going to be find the E cell. Find E cell for our zinc copper cell if zinc ions equal 5 molar and the copper ions equal 0.30 molar. Alright, one thing I don't think we had in our notes the other day was what does this equation really look like? And if you have kind of your notes out and look at that, we had zinc was the anode and copper was the cathode. So our equation really looks like this. Copper 2 plus zinc yields copper plus zinc ion. Alright? And that was balanced. We had 2 electrons in each of our half reactions, so we're transferring 2 electrons, and that's what we got. Okay? So, real quick, if we just solve for E cell, we're going to have 1.1 volts minus 0.0592 all over 2 electrons were transferred, so that is our N, and then we're going to have a log of products over reactants. Alright, and a couple things. Zinc is a solid, so it's not going to be in our Q relationship, and copper is a solid, so it's really just going to be zinc concentration divided by copper concentration. So our zinc is 5 molar, and our copper was 0.3 molar. Alright, so somewhere we're going to take 5 divided by 3, take the log of that, multiply it by 0.052 divided by 2, and subtract it from 1.1 volts, and we get an answer that is 1.06 volts. Alright, so our voltage went down by changing our concentrations. So, if we look at this in terms of Le Chatelier's principle, alright, or really just in terms of our knowledge of Q. So, zinc is 5 molar. Looks like a 6, low rate 6. Alright, so zinc is 5 molar right now. And copper is 0.3 molar. Alright? Our standard conditions are these should each be 1 molar apiece. So if we think in terms of Q, 5, alright, is too big. It's much bigger than 1. 0.3 is less than 1. So really we have too much product and not enough reactant. Alright? So the Le Chatelier-like, and again this is not Le Chatelier's principle because it's not really a stress, it's just we've made this. We've decided on these concentrations, but in an AP question you could say, this is a Le Chatelier-like principle where we have too much product, or we have a lot more product than we should have at equilibrium. So this is going to shift this way, alright, to get back to make our Q back to our K. And in doing that, we're going to impede the flow of electrons. So we have less electrons going forward, which means our voltage is going to decrease. Alright? Hopefully that kind of makes sense in terms of Le Chatelier. If you have to calculate it out, we can calculate it very easily. However, this could be a non-calculator based problem, questions 4, 5, and 6 in the AP test, and this is a way that you could reason it out without having a calculator, where it just might say, would the E cell be greater than or less than the E cell not, okay, or the E cell at standard conditions. So one other example, which is going to include our magnesium aluminum example from podcast 14.1, and it's going to be this example. Find E cell for the magnesium aluminum cell if aluminum concentration equals 2 molar and our magnesium concentration equals 0.5 molar. Alright, in this equation, again, it should be in your notes, but I'll jot it down real quick. It was, when it was balanced, let me find it. It was 2 aluminum ions plus 3 magnesium metals, or solids, yield 2 aluminum metals and 3 magnesium ions. Alright, and again, we are transferring 6 electrons here. Our half cell for aluminum had 3 electrons, our half cell for magnesium had 2, and then we had to multiply it to get our coefficients the way they are. Alright? So again, if we just eyeball this, what's going to happen to our voltage? Our magnesium concentration is 0.5, so it's less than standard, which is 1, and our aluminum is 2 molar, so it is more concentrated than it should be. So our equation is really going to shift to the products, and if it shifts to the products, we're going to have more electrons, so our voltage should go up, and we're going to see if that is indeed the case. Alright, so if we see our Nernst equation again, our good Nernst equation, we're going to have E cell Get a little more space. Whoa. We have E cell. E cell is going to equal, and if we look back from podcast 14.1, 0.71 volts was just our original E cell, or our E cell naught. We're going to take that minus 0.0592 over 6 moles of electrons this time. Alright? And then we're going to take the log, and this is where it gets tricky and where the AP test will get you. Our products are 0.5, alright? And our reactants are 2, and if you leave it like this, you are not going to get the right answer. How come? Because Q, again, is stoichiometrically based. Alright? So, how many moles of magnesium ion do we have? 3, so we need to cube this. How many moles of aluminum ions do we have? 2, so we need to square this. Alright? So we're going to take 0.5 divided by 2. It's going to be a number less than 1, so we take the log of that. It's going to be a negative value, and if we have a negative times a negative, this becomes positive, and that's why our voltage is going to go up. So again, if we calculate this out in the calculator, we should get a voltage of 0.72 volts. So mathematically, we see that our voltage goes up. Le Chatelier-like, just kind of using the idea of Le Chatelier, we are introducing more molarity than is standard, so we should be transferring more electrons, and if we're transferring more electrons, our voltage should go up. So that is the Nernst equation. Just know how to use it. The main thing where they like to get you and get students is with these things right there. Alright? Q is stoichiometrically related, even though E is never stoichiometry related. Alright? That's it. Have a great night.